about similar figures. Before we begin, take a look at these four figures. In which figure is there a pair of similar figures shown? If you said figure 3, you would be correct. Now let's take a look at why figure 3 is similar while the others are not. Similar figures are figures that have the same shape and are proportional in size. When we say same shape, we don't just mean they're both triangles, or they're both rectangles, or they're both trapezoids, or something like that. What we mean by the same shape is that their corresponding angles must be congruent, which means they must be the same. So the actual angle measures of the shapes have to be the same in order for them to be similar. They can't just be any triangles, they have to be triangles that have the same angle measures. They also have to have corresponding sides that are proportional to one another, meaning they all have to be so many times bigger or smaller than one another based on the side lengths. Let's take a look at an example of where all of these things are true. So first, let's look at the angle measures. So the angles that correspond with one another in this case are angle A and X, B and Y, and C and Z. If we look at each pair of angles, we can tell that angle A and angle X look like they're the same size. B and Y, we know those are the same because they're both right angles, and C and Z also look the same. Sometimes we are given the actual angle measures, sometimes we are not. We just have to determine whether or not these angle measures look alike. Now, an example of another triangle that would not be similar would be, say, if I had one that maybe looked like this. This is not necessarily similar, or one that looks like this. I'm running out of space. I was trying to make that obtuse angle there. Here's one. These are not similar. While they're all triangles, they don't have the same angle measures as these two shown. So when we say they're both the same shape, we have to make sure that their angle measures are also the same. We are going to look at that first. Then we're going to look at the side lengths and determine if they're proportional. If the angle measures are the same, then the side lengths will be proportional. But if we aren't sure if the angle measures are equal or not, then by checking the side lengths to see if they're proportional, we can tell if they are or not. So let's look at the corresponding sides. So that's 6 and 9. That's a ratio of 6 to 9. We also have 8 and 12 that correspond with each other. They are the same side length, but on, we'll call this triangle A and we'll call this triangle B. So if we look at the smaller triangle first, 8 corresponds with 12 in the larger triangle. And then lastly, we have 10 and 15. Those correspond with one another. Now obviously these ratios all look different, but if we simplify them, we can determine if they're the same. So in this case, 6 and 9 can both be divided by 3, which gives us a ratio of 2 to 3. 8 and 12 can both be divided by 4, which also gives us a ratio of 2 to 3. And lastly, 10 and 15 can both be divided by 5, which gives us a ratio of 2 to 3. So this means that triangle A to triangle B has a consistent ratio of 2 to 3. So that means this is similar, they are proportional, which also means that all of our angle measures are actually the same. One other way you could determine this is you could look at the larger triangle and figure out how many times bigger is triangle B than triangle A. So for example, we could look at each of the 3 side lengths and we could divide 9 divided by 6, which is 1.5. So 9 is 1.5 times longer than 6. 12 divided by 8 is also 1.5. And then 15 divided by 10 is 1.5. So you can see that triangle B is 1.5 times bigger than triangle A, all on all three sides. So that means it's proportional, which means it's similar, and all of the angle measures would then be equal. If we know that two shapes or figures are similar, we can use that information to find missing side lengths. So in this case, let's assume that we know that these two shapes are similar to one another. These are quadrilaterals. They have four sides, 1, 2, 3, 4. There's no specific type of quadrilateral. It's not a trapezoid, it's not a rectangle, but it is a quadrilateral because it has four sides. And we can call this shape A and we can call this shape B. When you're trying to find the value of x here, that's this bottom missing side length, we can do this a couple different ways. We can set up a proportion, which a lot of people like because we are comfortable setting up proportion at this point, most likely. And it's organized and helps keep our work nice and neat. The other option is to figure out, like I mentioned before, how many times bigger is the larger shape than the smaller shape. Sometimes it just depends on which side the larger shape is on, the left or the right, but you can still figure out how many times bigger. I always like to do how many times bigger the larger one is than the smaller one, rather than doing how many times smaller is the smaller one. But those are two different options. So we'll start with option number one, which is using a proportion. So when you set up a proportion, you need two ratios. And they have to be corresponding sides. So we know that we want to include x in our proportion because that's what we're trying to find. And since x corresponds with 9, I'm going to do 9 over x just to keep, I like to look in order from left to right. So I'm going to put 9 on top, x on the bottom. Now, if you look at the rest of the shape, we have 1, 2, 3 other sides that we could possibly use for our second half of our proportion. But if we already know that the shapes are similar to one another, then all of the sides are proportional, so it doesn't matter what other pair you use here. So we can use 6 and 4. We can use this 6 and 4, or we can use 3 and 2. It really does not matter. Because you should get the same answer either way. So I'll show both. 6 over 4 is the same ratio as 3 over 2, it's just simplified. So if you use either one of those proportions to solve, you should get an answer of x equals 6. The other way to do it is to figure out how many times bigger is shape A than B. Well, we can't use x and 9. We can't use the missing side to figure that out. We have to use one of the other pairs of corresponding sides. So we want to figure out how many times bigger is shape A than B. So we can do 6 divided by 4, which gives us 1.5. Again, this one is also 1.5 times bigger, like the last one. We could also use 3 and 2. By doing 3 divided by 2. You could do both just to make sure that they're the same, or you could just try one because if we are being told that they're similar, then they should be the same. Now, if I'm trying to figure out x, in this case is a little different than our last example. 9 is 1.5 times bigger than x. So instead of multiplying 9 times 1.5, in this case we're going to divide 9 by 1.5 because we want it to get 1.5 times smaller, which gives us our answer of 6 inches. There's two ways you can solve that problem. Take a moment to give this one a try. Since 12 corresponds with 3, and 16 corresponds with 4, this bigger shape A is 4 times bigger than our smaller shape B. So you can divide 9 by 4 to get our value of x is one way you can do that, which is 2.25. Or you can use a proportion, choosing 12 and 3 or 16 and 4 as your ratio to compare 9 and x with. So you could do 12 over 3 equals 9 over x, or 16 over 4 equals 9 over x. So notice I always go from left to right. If I put the 12 on top and the 3 on the bottom, then I also want to put the 9 on top. So if I put shape A on top here, I also have to put shape A on top here. So we just want to make sure we stay consistent with which shape we're putting on top. Now in this example, in your notes, you can see that we have two triangles, but one is kind of rotated a little bit. So when we see sometimes shapes that are similar, but they're rotated, we have to be extra careful when we're figuring out which sides correspond with one another. So I like to try to find either the biggest or the smallest side and then match that up first. That usually helps us out a little bit. So in this case, 3 centimeters is going to correspond with this 1.5 centimeters. So you can see it kind of tipped on its point here, this point, so that 3 corresponds with 1.5, which means that x then corresponds with 5 centimeters. If I'm going to also match up the 6 and the 12, we can see those correspond. I can use any of those. I can use either 3 and 1.5 or 6 and 12 to figure out our missing values. So you can set up a proportion. We'll call this shape A again, the bigger one. 3 over 1.5. And then I want to use x, because that's our missing side, not 12, over 5. Again, you could also, instead of using 3 and 1.5, you could use 12 and 6 instead. But we do have to use the x and the 5 because that's the one that's missing. So either of those proportions will work. And the other option, of course, as we mentioned, is to figure out how many times bigger is shape A than B. In this case, it's 2 times bigger. So if shape A is twice as big as shape B, that means x would have to be 10 centimeters because 5 times 2 is 10. Take a moment to try this example. In this example, x is 5 centimeters because this shape B is 5 times smaller. Doesn't look like it, but based on the measurements, it's 5 times smaller than shape A. Here's another one to try for you. In this case, these two sides correspond with one another. And so if I write a proportion maybe for this one, because trying to figure out how many times bigger this shape is than this might not be as easy because of the decimals. 8.4 over x equals 3.5 over 5 is a good proportion to use. Again, you could figure out how many times bigger 5 is than 3.5, but you'll get this long decimal that's not always easy to use. So sometimes the proportions are a bit easier. And in this case, you should get x equals 12. Finally, determine whether each statement is always, sometimes, or never true, and then explain. Rectangles are similar. This is sometimes true because while we know they all have to have right angles, they don't all have to have the same proportion. So for example, I can have this tall and thin one, or I can have one that is a little bit taller but also wider. Those are certainly not proportional to one another. You could also flip it on its side, but you can see that they don't have to be proportional, but also they can be if I want them to be. The second question says squares are similar, and that is always true because all squares have 4 equal sides. So no matter how big or small you make them, all the sides are always going to be equal. So they have to be proportional.